There we are.
I don't know if that one time we just took a picture.
Yeah.
We've learned our lesson. And she was like, make sure you guys record it next time.
I think this is mine. Is this one yours?
Yeah, because the first one's wrong.
Me too. I didn't know.
I thought it was ampicillin.
Me too.
But it's not
That's what-
ampicillin?
No, it's not.
It's the other
I
one.
don't know where she got that from because it wasn't on there.
I was like,
A bunch of the stuff wasn't on there. Like that
I
one
was
where
just
it's
really
like calculate the
confusing.
spaces between them. I didn't know how to do
14?
13.
that until.
But there's nothing 14 on here.
Oh,
That's
the
the
final.
test.
Okay, I was like, no. Okay.
Yeah, you put ampicillin too.
Okay, I second guessed myself for a long time because it's like, it said it weird, but I was like, but it says ampicillin resistance.
Uh-huh.
And so then I just changed my answer and got it wrong.
So why is it tetracycline?
So it says, which antibiotics should be added to the medium to select for cells that have incorporated a recombinant transcript? So what's a recombinant? Wouldn't it be this?
I'd say this material should not be in the test.
Well, did it even mention tetracycline in the notes?
No.
Or is it just because it has it on there?
It's just because I have the wrong one.
On there, I think. It's just supposed to be just a antibiotic, I think. Dang it. It says I was doing this really quickly. No one has to do
Me
that.
too. I think I got them like all right.
Yeah, me too.
I got 2C right.
Which was
2.
me too. You got 4.
Well, isn't it because you do it like, isn't it like 2 times 2? That's what I was.
I got really
How many
confused because I was
bands
like,
would you
if you
see on
cut
the
it
show?
right here, wouldn't that just be 2 strands? But then why is this one like 3 or something?
Besides it just a recombinant thing. Okay. How many bands would you see on the gel?
I'm pretty sure. So this, I'm pretty sure that's wrong because it should be half of that. It starts with 1, doesn't start with 2. So there's 15 cycles. Then to get to 2, doesn't it have to be 1? Like,
Yeah. Wait. So are we number 42 now?
no, I was just sorry. I was just
Oh.
looking ahead to see what.
Oh. I was very confused where you were.
My bad. I will wait.
Okay. So I don't understand why this is 2 and then 3.
See, why? So what's the question?
Did
You
put
decide to digest.
No,
I put 2.
I put 2.
I think that's apparently nothing. I thought I put an answer.
Is it down here?
Oh.
Oh,
yeah.
4.
4.
Wait, so which one are we on right now?
So
1.
2C or 1C and D.
Okay.
Vector plus insert.
Oh, no.
So why?
I just thought because if you cut right here and right here, you'd have this big one and this little.
Okay. But then
But
why
then
is
when you
D3? Because it's PSTL in that one.
You just-
yeah, see that's right.
Are they counting the origin of replication? No. That doesn't make
Are
sense.
they counting like the
Come on.
mistakes that could happen?
The what? The mistake?
Like if something wasn't
Mm.
um,
Well, see, I was going by this here, and according to this, there should be 2 bands, right? I mean, what's the question is,
For PSTL?
which ones are we?
for C, it's BEM, HI, and equal are 1.
Yeah. Wait, there's only one. Oh, down here. Okay. There's two here, right?
And then BAM, HI, and CS.
Yeah, there's only two there.
Yeah, it only has 2.
Oh, not probably she. I think it's actually the person.
Well, is it because it has
Right,
the
so-
E-core, I think, too?
Is it, I think the same one.
Yeah, I think that's what it might be, because if you include the E-core...
But it doesn't have that here. See, it just has the 2 listed.
Yeah.
Yeah, so that one's probably wrong.
Maybe that's what they're trying to mean. They just didn't write it clearly enough.
Yeah.
I feel like with this kind of unit, like, or this chapter or whatever, like I feel like it's harder to know, harder to understand. I'm not doing this stuff. I don't know. Like
It was
reading about
very
it.
unclear from the notes and everything what
Yeah.
to do about it.
Yeah, I thought you multiplied it twice.
I just looked at the video, and it had it there. And it's like, this is like a million or something. It's like in a different...
I got this except that I thought that because of how it
Is
started.
this yours? This one's mine.
Yeah.
Alright, so 2A.
Okay. When did you guys get? The question was, describe what would happen in a PCR experiment if you only used one primer instead of 2 primers.
I didn't really know how to explain it, but pretty much like, only, like, you wouldn't get the smaller segment.
Yeah, it only went to one
It
side.
would only go to one side, and so you would just get that side.
Yeah.
I thought it just wasn't going to do it at all because you needed 2 to enclose it. Like one on each
I think that's what we're saying this year.
Yeah, because it would do that, and then
Like
the
the
one that,
vinyl into one side, and then it'd be opening on the side, so it's just one side. So I wouldn't be able to close it. That's what I kind of idea.
Okay, I guess that's what I was saying.
What did she say? Is it the shoe?
No, she doesn't do this.
Yeah.
Well, I don't think so. Maybe she
I don't think she does. I think probably online it's very generalized.
Yeah.
Yeah, I think she just organizes it.
She's right there.
Okay, each primer.
Yeah, that one I was just gonna talk about like there's like the kind of neuron, neurons that are traveling, and then ATPase on the mice.
only one
and then-
template in the external would be copy. Yeah,
Yeah. Yeah.
but it'd just be like a normal like copy, right?
I think so.
It would just be.
But when
So here's like your giant piece of DNA, and you would have your primer that's right here, and let's say it's going this way, you would just have
Copy
this
everything
part.
on that side.
Yeah, and then you just wouldn't have this. You'd have like the template of that, but then you would just have the left.
Okay.
I think they have. I
Okay.
think Fast Twitch have.
And then B. Are we good with A then?
Yeah, so I talked about
Okay.
that one too.
B. Did you guys? I got that, but only half of that because how I understood it is because you start with 1, then after one cycle you don't you add 2.
Well, I put 30 because I thought like double.
But that's the number of cycles. It doubles each time, but it doubles each cycle. So it starts with 1, and then goes to 2, and 4, and then 8, 16, 32, 64. But see, the thing I didn't get because I from what I understand, it says here, using only one copy of a double-stranded DNA molecule. Okay, but it's double-stranded though. But it's still after the first one. I think it was only 2, right? Going back to the PowerPoint. That's the wrong PowerPoint. That's from the,
32,700.
well, that's 2 to the 15th. But what I understood is
I
that
had like 30.
And maybe you wanted to put a comment.
I also talked about how it's time.
because the first time, let's see here,
Well, that makes sense.
It's just that it doubles every time,
But
but
yeah.
15 times.
so that's what I know. But the very first time though, wouldn't it not like it would take one time to get up to 2? Does that make sense? So like the very first time, it's at 1. So if you double 1, that's 2.
So limiting him to 70%.
So if one, I mean, like, I guess I'm just not understanding this right, but if that was the case, then it should be half It should be 2 to the 14 because it's 1 times 2. Does that make sense to you guys?
Yeah.
I think it just means like after, but like if you think about it, after the first cycle in the PCR, you would have 2 copies.
2 copies, but they're not complete copies yet. They're only one-sided copies. They're not.
But it's like, it's how many
But they're eventually
strands.
gonna
It's
be-
not how many like perfect ones.
Yeah.
Okay.
You'll
I think
eventually
it's what they're
have that number of.
That makes sense. Okay, and then it's
So
per
like
cycle.
you start, you put it
You
in,
go
but
through
at
one
the end
cycle.
of the cycle.
Okay, yeah,
Yeah.
that makes sense. That makes sense because each cycle. Cool.
So if it was like the start of the 15th cycle, then it doesn't
Yeah, I was gonna say,
Yeah, 'cause yeah, I just was thinking better on. Cool. Alright, are we good with B then?
Yeah.
Okay. C. I can read it again, I guess. We usually think of enzymes being most active at around 37 degrees Celsius in body temperature. In PCR, however, DNA synthesis occurs at 72 degrees Celsius during each cycle. What is unique about the DNA polymerase that is used in PCR?
It's just that it was like thermostable,
Yeah.
so it wasn't going to denature like the other ones.
That's what I said too. That's what she said basically. Cool. Gene.
Yeah. No, I was just looking at comparing it. I put them backwards. DNTP lacks 2 of them, and then DNTP lacks 1.
Don't you remember deoxyribose? So ribose has like the 2 hydroxyl groups right here, and then deoxy is missing the one here.
Right.
So dideoxy would be missing this one here too.
Right. So it'd be wouldn't dideoxy be missing 2?
Yeah.
Oh, that's what I put. Wait, is this one mine?
Yeah.
Oh, okay. Just kidding.
So dideoxynucleotide is missing.
Yeah, that's what
Oh, okay. Yeah.
I don't know where you were looking.
I think I.
Did you look at this
I
and think it was di?
Yeah.
Because of the one above
yeah,
it. Oh,
yeah.
okay. I was like,
I thought you put it backwards. On. Yeah. Okay. Yeah. Never mind.
just at least.
Is that what you got? Too?
Yeah, so
did she put my
NTP. So this says the nucleotide would have a hydroxyl group at the 2' and 3' position. Is that what all NTPs though?
Is that all what?
Is that all NTPs though? They have that because
I think so.
Yeah, because the NTP is without an oxygen.
yeah.
So NTP was technically RNA or whatever. Could it be ribose?
Okay. That makes sense.
I don't know why they call it that. It'd be more clear if they called it RNTPs or something.
Yeah. I think they do sometimes in some. Yeah, I can't remember what we should look at it. That could just be like a wrong way of saying that too.
Yeah.
That makes sense. Yeah, then the NTP I put. Yeah, the same thing.
Okay.
For each thing.
I had no clue how to do 3. I
didn't
just
either.
multiplied a bunch of things.
Yeah, me too.
I completely just guessed.
I didn't
Like
know I was supposed to do it for
approximately
each
1,000.
one.
But me too. And then I saw her explanation on the discussion board, like later.
What did she say?
I can't remember, but it's basically you multiply, like, I think you multiply the percentage. Oh, I remember. So you multiply each one
By its percentage.
Mhm.
Oh,
So if
that's
this
easy.
one has like 1A, then that means you multiply times 0.3. So 0.3 and then 1G would be times.
So it'd be 0.3
So you just multiply-
plus 0.2
No,
Times.
times
So you multiply. So this one's 0.3 times 0.2 times 0.2
0.2
times
times
0.3.
Oh.
And that's how she got that number. And then you divide
That makes
that's
sense.
1 over that number is the number of base pairs.
With 1 over that
One
number.
over that.
Number.
Yeah, 1 over this.
Why is that?
I don't know.
Okay. Well, so
There wasn't notes or anything on that, was there?
No, there wasn't anything.
yeah,
Oh, of course.
that's why it's so that's simple. I mean, like
Mhm.
that's not hard at all to figure out.
No, so yeah, so like on the second one, then it's just 0.2 times 0.2 times 0.2 times 0.2.
yeah.
Is that what she did?
0.3 times 0.3 times 0.3
Yeah.
times 0.3 times
And then went over
0.3.
that.
Yeah.
Okay.
Wait,
So
so
that's
if
how many
you,
base
if
pairs.
you have a repeat though, do you just multiply it again? Like,
Or do you do 0.3 times, or
0.2.
0.2 times this 1, 2, 3, like that'd just be all of them. Can you do 0.3 times 1, 2, 3, 4, 5, 6, 7, 8?
it looks like they just yeah.
Yeah, just keep on going.
So you multiply it by each one that's under. Right?
Just went over that.
Yeah. Wait, but for D they only. Oh, yeah. Yeah, that makes sense.
Yeah, cool. Understand that now. For 4, where's 4? I think it's blank.
Oh, my force right here.
This was all it was, right?
No, I think for A. Oh, wait, yeah.
This
what would
is
be
the
the
one
banding
that
pattern
just
look
had
like?
the bold.
Yeah, what would be the banding pattern?
What did you guys get for that?
So the first one is G, and then the next two A, and then C, T, A, G, T, A, T, T, C, G, G.
Well, I guess if you want
Okay,
to.
that's not what I
I got what you got.
I got G, G, C, T, T.
How's this red just going up like this, right?
Yeah, it just goes by.
But I thought it went by 5 primes, because you guys are going by 3 primes. I thought 5
I
prime
think
was
so.
that.
Well, I think she got what you got.
Yeah.
Oh, yeah, she did.
So wait, so what did we do wrong?
Okay,
if we
so
put
the
our
primer
side down-
annealing
oh.
site is right here, so it's gonna start by this C. It's gonna be the 5 prime
Oh,
site,
okay.
and it goes from 5 prime
There's
to
the
3
5
prime.
primes on that side.
So if I
doesn't-
did it like this, then that would be right.
Yeah.
So it would be
So it should
G,
be like this.
A, A.
C, T, yeah.
So it goes. So it's supposed to be 5 prime starts down
Yeah.
here.
So you have 3 prime
So it's really
and
just
5
going.
prime.
So what we got, we're going the opposite way.
Yeah.
Okay.
Okay, so my question on this is, how do you? So you figure out the sequence by this, like the new sequence that you made. So it'd be like G, A, A.
Uh-huh.
So
It shows you what the
so
sequence
the
is, right?
idea is that you don't know this section right here. And so when you put it in like that, this is what you're going to get back, and this is how you find this, and then you can find them.
What you replicate.
Yeah. Because obviously if you're given that, you can just be like, well, it's
Right.
this. you
Yeah.
know?
Okay.
So in this sense, because we don't have, like, obviously a PCR machine to do this like ourselves, they have to give us the sequence.
But normally, we do it backwards, right? So you get this, you would do this.
So, like what we always did in lab for 377 is we would do like a little research thing, and it would tell us like where like a specific gene was, and they'd like a lot of times like they would give us like the primers that they used, or they'd like have the sequence of the primers, and then you order them, and then you put them in, and then you get back what you put in. So like you don't know what you're gonna get, and then you need to.
So you once you use the machine to get
PCR,
this, to get this, and then this here is tells you what to do.
Mm-hmm.
Cool.
Yeah. And then by looking at this, you know what this is.
Oh yeah, it's still going.
Can you see what time
Oh.
we're at?
We're at like 20-ish.
20. Yeah. Okay, so if they say, so like if you stick one of these in but not the others, what would that do?
So if you only stuck one in, it would just like stop once it hits like a T.
So let's say we only put DDGTP.
So if you only put
It would only
DDGTP,
show these
it would
lines.
go until it just do C.
It would only show these lines.
No,
No,
it would only show
these.
that one.
These two, right? Because
This is backwards. Remember,
Oh, I go backwards.
it's C
So it
first.
only show this one.
So, well, here's the thing. is not every time it's going to put a DDGTP instead of a normal DGTP. And so it's just whenever that one gets put on there. So whenever there's a C in here, so it could either put one right there or right there. That's where it's just going to stop.
But you could have either or.
Yeah, so you could have just this one G, or you could have it stop there. Or that's why they do it over and over again, because they get this little sequence and then this little sequence. And then
I guess that's why I'm confused, because then how do you know which one's going to happen?
you don't. That's why.
That's
That's
what
why
you do,
you
right?
do 32,738. That's why you do like a bunch of cycles, because you don't know,
To know which one it will
Yeah.
be.
because it's very random.
So with that, would it just show if we only put in DDGTP, would it only show these two because these two are the very first two?
Yeah, if you did it more than one cycle,
So one time it would show the first one time it could show the second one.
or one time it could show
The
that
third
one.
So it could show all of those. Okay, that's what I was trying to say.
And why could it show any of those?
Because it will only do it one time. It'll only put in the DDGTP
Because then
one
it's just
time.
done.
Yeah.
Because you can't add more.
But if it doesn't do it in the first C, with the first C that it interacts with, then it'll
it
keep
could
going.
do it. And then
Okay, so then when you like this here would be the product of several cycles, many cycles. Okay.
So you would
well,
get
this here has all of them in there.
right.
And so it stops them like at a bunch of different ones after like a bunch of different things.
Right. So my question with that is, so you get all these different pieces, and from there you derive a sequence of DNA. Are they all just going to mix up or what?
What?
You know, like, because this is saying you get all these pieces, right?
Mm-hmm.
That's what we're mapping out here. So how does this turn into a sequence of DNA right here?
It's how far it's by like how far it travels. So I guess what's like the two key points are how far it travels and what color it is. So like all of these different ones, like you would say T is blue and G is yellow and A is pink or whatever. And so then when you look at it and see, okay, well, a blue G went the farthest on the gel. That's got to be the closest thing to our primer. And then a pink A was the second closest. So that's going to be the second thing closest to our primer. Like that.
Oh, okay. So these aren't actually, these are just indicating what. I don't know how to word it, but they're not.
This
actually
is where
indicating
it was
replication.
added.
Right. Okay.
Yeah.
Okay.
This is where it was added to stop the strand. And the reason why it like goes up like this, so heavier goes less far.
Yeah.
The
so
small stuff can run through all the pores and go to the bottom.
I guess so. So what I'm saying is that the strand doesn't come off of this. This is mapping out what the strand actually is.
Mm-hmm.
Okay.
So there's nothing with the pieces of the
This is
strand.
the mapping out the pieces.
Because we don't know what it is.
Yeah.
This is mapping it out for you. And since you put this in a stop right here, then there's an A right there, or a G right there.
Yeah.
Oh. Okay, that makes sense. You're so smart.
It's just because of 377, really.
Oh, really?
Yeah.
Taking that class
I mean,
next
I mean,
semester.
it made sense to me. Like, it made sense what they were doing as far as gel mapping because I've done it before in another class. But I didn't understand what the whole like DNA strand thing was. And when I like ran into other problems, I was like, I don't know what you're talking about.
Yeah. It's like, it's weird because like a lot of it came back. Like, all of the videos were super simple. And like,
Yeah, I watched one of them.
that didn't help with any of like the harder problems on here. So, okay.
Okay, I didn't do number 5.
Me neither.
I did number 5, but I did the last two wrong because it's asking for a linear restriction map and a plasmid restriction map, and I just did the normal like restriction map that they have on the PowerPoint, which was just like this.
Okay. Well, let's just go over it.
Yeah.
Okay. So, A.
So did A right.
Bam, HI, and
Oops, sorry.
base pairs.
So it pretty much tells you where the banding is going to be of these three things, and then it gives you a marker, or we call it a ladder.
So you just have to like basically put it
So you
together.
put the ladder in, and then you match your samples up as best you can to the ladder.
Why do you have one at 110?
I have no clue.
Oh, you have the markers. These are just
Oh yeah, this
regular
is the
markers.
marker.
Oh, okay.
That's the ladder, yeah.
So the first one was at 400.
So
No.
BAM,
Yeah.
HI is right here. And so 400 is going to be a little bit below 500. And then 1200 is going to be a little bit above 1,000. And then 24 is going to be a little less than halfway between 2,000 and 3,000.
And it always goes positive electrode on the bottom and negative on top, right?
Yeah,
And then
because
the larger pieces are attracted to the negative electrode.
so the negative backbone is attracted. Remember the phos?
Okay, yeah.
The negative backbone of those longer ones is attracted.
Well, they're all attracted to it, but it's which one. So there's like two factors. There's like, they're all going to be attracted to the positive because they all have negatives. But if they're like a bigger strand, they're not going to go as far because they're not going to be able to get through the pores as easily at the rate that you stop it. So if you let your gel run for like a really long time, like they would all just run off. Like that happened before in an experiment that we did where we were testing. Well, it was like our final in that class,
Oh, good.
and so we like ran our gel, and then we looked at it under. You have to look at it under like a certain light, and it was just like blank. Like our marker was like barely on there, and like all of our samples were like gone, and we're like, what the heck is going on? And so we thought we had to like start all the way over. But then Brother Higginbotham was like, well, why don't you run your gel at this voltage for this amount of time instead? And that's what it was. We had ran our samples completely off our gel because we ran it too long. So technically they would all get through it, but the speed is by how small it is.
So you can
So
say
it's positive and then two negative and then 5 prime. Alright. B.
So B wanted linear, and I don't know how to do that. We're gonna have to look at hers.
Complete with the individual restriction inside and then your foundation transfer. A linear restriction. So small goes to 2,000 and then.
But higher they're.
Why are they out of order?
That's what I was wondering.
I see. I don't know what's in between.
Because you would think that it'd be like the 500 would be over there, right?
Yeah. You could put it in.
Small and then.
Okay, so this might. I don't know if this is right. So if it's just cut with small, you're gonna have one that's 2,000. You're gonna have one that's 5,500. So if you cut it right there, you have 2,000. You have 5,500.
Right.
If you cut it with times 3, you're gonna have 2,500 and 5,000.
Yeah, that makes
That's what
sense.
it is.
Yeah.
Okay.
So what does that mean, though?
What do you mean?
Like, I understand that that's like kind of like what the numbers mean, but like for genetics, why? What's that saying? Like that.
You're gonna know if you use the right restricted enzyme and restrictive site if you have the right amount of base pairs. That's pretty much what that's saying. So if you wanted to do SMAI, but you got two segments that were 100 base pairs and 6,000 base pairs, you'd be like, I did something wrong. I messed up. I have to do this again. So that's the only thing I know that was helpful.
Yep.
Okay. So then the next thing is probably the same for this one, but circular. So
It's kind of like a puzzle, basically. Oh, wait.
yeah.
Oh, yeah. So she's just basically putting them in the order where if you...
So look at this. So this one only has one. So you know if you cut it, it's going to be, here's your circle, and you just cut it once, it's going to be like that. And you're just going to have one piece, right?
Mm-hmm.
And so you know the whole diameter of the circle is going to be 5,200. That makes sense.
And that's why she put it on top.
Yeah, and so then you have to go to a point where it's going to be like 2,600.
She's gonna match them all up.
Yeah.
So SAC1 or SAC1 believes that those.
So it's going to have multiple restriction sites, is what it's going to do, to have that many.
What does this mean down here? This cloud.
Yeah, together.
Together. So if you cut it here, and then if you cut it up.
So it'd be like here and here, you would have one that's this long and then this long, right?
Yeah.
Yeah,
so,
if you cut it with this one you have one that's
but
1,200.
you're cutting all of them, so you're going to have this segment,
Right.
this segment, this segment, this segment.
Oh.
Okay, so this is with using both of them. Okay,
Oh, you have all those segments.
Yeah.
that makes sense.
Because if you cut one sac-eye, you're going to cut them all.
Mm-hmm.
So with just so this right here is the 2,600 right there. Yeah, it is 14. Okay, cool. Makes sense. Yay!
This lesson is interesting.
Yeah, going over it wasn't like as complicated as I thought it was.
No.
Like doing this like on Wednesday, I was just like, this is ridiculous. What are we at right now? Oh, good.